Welcome to Subatomic Tanvi. Topic for today is the what now principle.
Heisenberg's uncertainty principle. And by the way, hi everyone.
So you're going to show an experiment, a DIY experiment to prove the Heisenberg's uncertainty principle at home.
Yes.
So before we do that, can we quickly recap what the Heisenberg's uncertainty principle is?
Yeah, sure. So, the Heisenberg's uncertainty principle states that you cannot accurately measure the position and momentum of a subatomic particle at the same time. And the experiment that Heisenberg did was he took a moving electron and gamma rays. So he passed gamma rays onto that moving electron, which changed the momentum of the electron a little bit. And that's why Heisenberg was never able to accurately measure the position and momentum of that electron at the same time.
Well, I'm not Heisenberg. You're not either. So, and we don't have gamma rays or electrons. So how on earth are you going to show that experiment at home?
So, when I did the experiment, instead of using the exact materials, I used completely safe alternatives for the materials that still makes the experiment work perfectly. And I actually have a slideshow to show that, and I'm bringing that up right now. So here it is. So let's watch this video. So this is a laser light, and I'm bringing my fingers close to each other slowly until it eventually blocks the light out from the laser light, just like that. So there. And now let's see this video. So this is the light that from the laser light that comes on the wall. So as I get my fingers close to each other slowly like this, what do you think is going to happen? That this circle on the wall is going to get smaller and smaller and smaller until it disappears completely, right? Well, instead of that, something rather strange happens. Watch this. I'm bringing my fingers close to each other, and look at that. The light from the laser light started spreading instead of making the circle of laser light on the wall get smaller. So now the light is gone, and now it's back to the full circle of light. I'm bringing my fingers closer to each other, and it's spreading out on the wall again horizontally. So yeah. And that happened because the momentum changed. So if there was no change in the momentum, it's just going to appear as the full circle, and it'll keep gradually getting smaller until it disappears. Just like how you saw it as a full circle at the beginning of the video, like this. But if there is the change in momentum, which is how it's supposed to be, instead of all of the photons hitting the same place over and over again and making the circle like this, they hit everywhere like this. So the light spreads horizontally on the wall. So that's why this is happening, because the momentum is changing. So these are my fingers, this is the laser light. So the distance between both of my fingers, we'll say that's delta x. And this is the spread out light on the wall, approximately spreading out from this arrow to this arrow. And we'll call this distance here delta p. So this is the equation for the Heisenberg's uncertainty principle. Delta x times delta p is greater than or equal to h by 4 pi. So delta x is the uncertainty in position, delta p is the uncertainty in momentum, And this h in h by 4 pi is Planck's constant. So, the uncertainty in momentum, this is the change in momentum. So, that's what happened when the light was spreading out on the wall in our experiment. The momentum was changing. So if that momentum didn't change, that would mean that the momentum, that delta P is 0. And since anything times 0 is equal to 0, delta X times delta P would equal to 0. And 0 is not greater than or equal to h by 4 pi. So if the momentum did not change in the experiment, that would actually violate the whole principle because it would be false. And here's a little fun fact. The value of Planck's constant, which is this h right here, is equal to 6.6260715 times 10 to the power of negative 34. That is extremely small. Can you even imagine how small that number is? So this is the equation for the Heisenberg's uncertainty principle, and also the videos from my experiment that proved the equation correct.
That is amazing. I am speechless. That is spooky beautiful.
I mean, everything quantum is beautiful.
Thanks, Subatomic Tanvi. This was an excellent experiment. I hope everyone who watched and listened get to do this experiment at home as well.